A logic gate is a basic building block of a digital circuit that has two inputs and one output. The relationship between the input and the output is based on a certain logic. These gates are implemented using electronic switches like transistors and diodes. The basic logic gates are categorized into 7: AND, OR, XOR, NAND, NOR, XNOR, and NOT. Before we go further, my name is Syed Haziq Hafiz bin Syed Haziq, matric number 1916935. What is an AND gate? An AND gate is a logic gate having two or more inputs and a single output. An AND gate operates on logical multiplication rules. In this gate, if either of the input is low, then the output is also low. If all of the inputs are high, then the output will also be high. There are two binary digits, 0 and 1, which is so that an AND gate performs a binary multiplication of binary digits. In multiplying 0 with 0, we will get 0. 1 with 0 or 0 with 1, we will get 0. Only we get 1 when 1 is multiplied by 1. In other words, an AND gate is a digital device that produces high output only when all inputs are high and produces low output under all other inputs in conditions. A high digital signal means logically 1, and a low digital signal means logically 0. An AND gate may have any number of input probes, but only one output probe. Two-input AND gate. The symbol for a two-input AND gate is logically represented, where A and B represent the input of the gate and X represents the output. A, B, and X can either be 0 or 1 logically. The logical operation of AND gate hence can be represented as AB equal to X. All multiplication combinations of A and B can be represented in tabular form in a truth table. Truth tables list the output of a particular digital logic circuit for all the possible combinations of its inputs. The next one is AND gate circuit diagram. Normally, an AND gate is designed by either diodes or transistors. When diodes are used to design AND gate, it is called a diode AND gate. The basic circuit of a diode AND gate is shown below.
Assalamualaikum warahmatullahi wabarakatuh. I am Tasnuva Tasnia and I have chosen the OR gate. So what is OR gate? An OR gate is a digital logic gate that gives an output of 1 when any of its inputs are 1. Otherwise, it gives the output 0. An OR gate performs like two switches in parallel supplying a light, so that when either of the switches is closed, the light is on. A starting point generator is connected to one input of the OR gate and digital processor unit is connected to the other input. Here is the symbol of OR gate. Here, two inputs are going like A and B in OR gate. There is a summary of OR gate A plus B equals to F. And here is the truth table of OR gate. So when we take inputs for A and B, like suppose A is 0 and input B is 0, the output will be 0. And when the input A is 0, input B is 1, the output will be 1. When input A is 1, input B is 0, the output will be 1. And when the input A is 1, and input B is also 1, the output will also be 1. So from the truth table we can see, like whenever any of the switch gates are 1, like any of the switches are on, the output is always 1, like it's always on. Also, when we see the circuit diagram of an OR gate, here two switches are parallelly supplying a light. So when, like if switch A is on, and switch B is off, the light will still light up. And if the switch B is on and A is off, the light will still light up. When both of the switches are on, the light will be light up as well. And only, like we have seen in the truth table, like 0 inputs for both inputs are 0, the output will be 0, like that. If both of the switches are off, only then the light will not light up. So that's all from my part, logic gates in OR gate. So I hope you enjoyed the presentation. Thank you so much. Assalamu alaikum. Take care and stay safe.
In my part, I will explain XOR gate. X is coming from exclusive word. XOR, it can call inequality gate. Why? Because we have in the truth table, only we can get the output, only it will be true when we have the both input is different. That's mean inequality inputs. And this the Boolean expression for XOR. What when we have three inputs? When we have three inputs, should we only focus about the odd true input because it will give us in the output true. If we have even true inputs, the output it will be false. Here in the last row we have three truth inputs. That means it's odd number, so the output it will be 1. Now I will explaining the AND gate. AND is coming from not and is two form, and this is the Boolean expression and this is the truth table. So now only just the difference in the last row is give us the output it will be false when we have the same input. Okay, if you can see in this circle, electronic circle, we have when we have 0 and 0, the input A and the input B will be 0, so the output it will be true. That means the lamp it will be open. The same thing for the three of them, but when we have input 1 it will be true and the input 2 also true, the output it will be 0. That means the lamp is not will be light.
Assalamu alaikum warahmatullahi wabarakatuh. Today I'm gonna present NOR gate. So the presenter is Fatina Muhammad Aliwa, metric number 1920218. So what is a NOR gate, right? NOR gate is a Boolean operator which gives the value of 1 if and only if all operands have a value of 0 and otherwise has a value of 0. The NOR gate is a circuit which produces an output signal only when there are no signals on any of the input connections. The NOR gate is a digital logic gate that implements logical NOR. It behaves according to the trust table. So here you may see the trust table. So according to the trust table, right? A high output results if both the inputs to the gate are low. If one or both input is high, a low output results 0. NOR is the result of the negation of the OR operator. It can also in some senses be seen as the inverse of an AND gate. So NOR is a functionally complete operation. NOR gates can be combined to generate any other logical function. It shares this property with the NAND gate. By contrast, the OR operator is monotonic as it can only change low to high, but not vice versa. So also I want to include that the original Apollo guidance computer used for 1,100 integrated circuits, each one containing only 3 input NOR gates. There are 3 symbols for NOR gates. the American symbol, the European or rectangular symbol, as well as the deprecated DIN symbol, DIN. So for more information, we may see the logic gate symbols, right? The NC symbol and ANSI symbol for the NOR gate is a standard OR gate with an inversion bubble connected. The bubble indicates that the function of the OR gate has been inverted. So the NOR gate has the property of functional completeness, which it shares with the NAND gate. That is, any other logical function like AND, OR, etc. can be implemented using only NOR gates. An entire processor can be created using NOR gates alone. So, as NAND gates are also functionally complete, if no specific NOR gates are available, of course, one can be made from NAND gates using NAND logic. Our next gate is the XNOR gate. So what is the XNOR gate, right? The XNOR gate, sometimes ENOR, EXNOR, or NXOR, and pronounced it as exclusive NOR, is a digital logic gate whose function is the logical complement of the exclusive or XOR gate. So the two-input version implements logical equality behaving according to the trust table. At the left you may see, and hence the gate is sometimes called an equivalence gate. A high output one results if both of the inputs to the gate are the same. If one but not both inputs are high, one allow output 0 results. So you may see also here the algebraic expression that used to represent the XNOR operation. So there are two symbols of XNOR gates, one with distinctive shape and one with rectangular shape and label. Both symbols for the XNOR gate are that of the XOR gate with an added inversion bubble. If a specific type of gate isn't available, a circuit that implements the same function can be constructed from other available gates. A circuit implementing an XNOR function can be trivially constructed from an XOR gate followed by a NOT gate. An XNOR gate circuit can be made from 4 NOT gates. In fact, both NAND and NOR gates are so-called universal gates, and any logical function can be constructed from either NAND logic or NOR logic alone. If the 4 NOR gates are replaced by NAND gates, this results in an XOR gate, which can be converted to an XNOR gate by inverting the output or one of the inputs. So this is the end of our presentation. Assalamu alaikum wa rahmatullahi wa barakatuh.
Assalamu alaikum wa rahmatullah. I hope we are all good with our family by the grace of Almighty Allah. Our group has chosen logic gate topic for our mini showcase. Before I am going to my point, we have to understand what is logic gate. Actually, logic gate is a kind of electronic circuit. When a Boolean algebra is applied in a digital electronic circuit, it is called logic gate, where only one output is available after giving one or more input. Now, the basic logic gate are classified into 7 types of logic gate, which are AND gate, OR gate, XOR gate, NAND gate, NOR gate, XNOR gate, and finally NOT gate. These 7 types of logic gate we have, and above our group members have already explained the 6 logic gates. I am Muhammad Rafiqul Islam is going to explain NOT gate, and also I will give the conclusion of our showcase. Actually, NOT gate is the gate of logical complement. It is also called inverter. That is the gate used to perform logical complementary work in Boolean algebra is called the NOT gate. This gate has a single input line and a single output line. Since NOT gate is the gate of logical complement, it follows the rules of logical complement. In the case of this gate, the output is the opposite of the input. That is, if the input signal is 0, output will be 1, or if the input signal is 1, the output will be 0. If we are talking about the circuit diagram, here light, switching, and emitter, here positive and negative volt we have. Here the switching circuit of the NOT gate has a single switch we have, which is connected in parallelly with the bulb. It is parallelly connected with the bulb. As a result, the bulb light up when the switch is off. Here off means 0 but does not light up when the switch is on. On means 1. And finally, we can conclude, we know a computer or electronic device understands only 0 and 1. It is worked through these 0 and 1. Here 1 refers to the presence of electricity and 0 refers to the absence of electricity. So logic gate or circuits can be implemented by using electronic components and verified by the Boolean algebra expression, truth table, and logic diagram. Thank you so much. Assalamu alaikum wa rahmatullah.